Hello everybody. In today's tutorial I'm going to explain a bit about the difference between a mutable class and an immutable class. We're going to see an example of why sometimes mutable classes can be a bit more dangerous, and I'll show you how you can transform a mutable class into an immutable class. So we'll start with this project that is already created. I assume you know how to do that. And I've created a package, column example, mutable example. And inside I've already created a skeleton of a main file that we're going to use. These are the steps that we're going to take to show an example of how a mutable class can be a bit dangerous. Step 1, we'll create two collections of points. Step 2, we'll create 2 points. Step 3, we'll add the points to the first collection. Step 4, we'll edit the points, which is also called mutating them, and we'll add them to the second collection. Then we'll see what happens. We'll start by creating the point class. We'll actually call it mutable point. And we're going to make a quick implementation here. First of all, although this is not completely relevant to the tutorial, we're not going to make this class public. We're actually going to make it package private, and we're going to make it final, so no subclasses can be made of it. We're going to add 2 fields, private double x and private double y. We'll make a quick public constructor, mutable point, that will accept 2 parameters, double x, double y, and we'll set those 2 parameters, this dot x, equals x, and this dot y equals y. Then, in order to make this class mutable, we're going to create public setters and getters. So we'll start with public the getter double get x, which receives no parameters and simply returns x, and the setter public void set x. This does receive a new value for x, and does the same as the constructor, sets x to the new value. We'll copy these for the y parameter. Sorry about that. And now we're done with our immutable point class. One more thing, just so we can actually see this work well, we're going to add an overrided toString method. Override public string toString. This will override the method in the object class. And what we do here is a quick string where we can show the point. So open parentheses, the x, a comma, the y, close parentheses. And that way we can print out a point. We go back to the main, and we'll start by creating the 2 collections of points. So we'll make a list of mutable points. We'll call it start locations, and it will be equal to a new array list of mutable points. We'll also, well, we have to actually do the imports. If you press, on a Mac, if you press Command-Shift-O, it will actually do the imports automatically. So we'll add list there. I'm not sure in other platforms what is the keyboard shortcut. We'll also add a second collection, which we'll call end locations. Now imagine we're programming some sort of game or some sort of application where we're going to show those points on the screen. Now we'll create 2 points, and we'll call them mutable point, my location, new mutable point. We'll place ourselves in 1, 1, and we'll copy this and make your location, and we'll place you in 10, 20. Now we're going to add these 2 points to the first collection. So we write start locations dot add and my location, and the same for your location. Now, at this point, we actually want to see what we've done, so I'm going to use system.out.println in order to show this. So I'll write start locations, 2 dots, and here we're actually going to use a handy library method, which is arrays.toString, and here we're going to take our start locations array list, and this is not actually an array yet, so we convert it to an array with the toArray method. That way it'll print it out nicely using this overrided toString method which we added to the mutable point class. So now that that's done, we can run it, and we see what we were expecting. Start locations is an array which contains 2 points, 1, 1 and 10, 20. So now the next step is we're going to edit these 2 points and we're going to add them to the second collection. Now, in what situation could this happen? At some point, maybe if in the course of the application being run, the positions, my position and your position, change. So in that case, it would be logical for us to take my location and edit it. How do we do that? We write my location dot, and we use the setter that we wrote. So we're actually going to place me in 100 and the y separately 100 as well. So now I am in position 100, 100. And we'll edit your location and we'll set it to -10 and -20 for the y. Now that we've edited the points, we're going to add them to the second collection. So end locations dot add my location and end locations dot add your location. And now that we're ready, we're going to print out this new collection to the screen. So this time the end locations arrays to strings, end locations to array. And we'll press play, we'll run it, and we see the following. Start locations appears to have 1, 1, 10, 20, which were the start locations, which is fine. End locations has 100, 100, -10, -20. Now, the problem is that if we, once again, without doing any changes, print out the start locations like this, and we run, we actually see that the start locations have changed. They are no longer 1, 1, and 20, but they are 100, 100, -10, -20, just like the end locations. This is because the mutable point class is mutable. And this is the danger of using mutable classes. When we have a larger program with many different sections of code working on the same objects, like for example here we had 2 different collections of mutable points working on the same points. If they are allowed to edit them, then they not only edit them for themselves, but they also edit the points for everyone else. So this is a bit this can be a bit confusing, and it can lead to errors in programming, which is why when appropriate, it is usually better to start at least with immutable classes. That is simply a class that cannot be modified. Now there's no aspect to the Java code, there's no language construct which lets us make a class immutable. It's simply a matter of what methods we give to access and mutate the data inside our class. In this example, the mutable point has getters and setters, and the presence of the setters is what actually makes this class mutable. So if we were to eliminate the setters, we would obtain an immutable class. Now I'm not going to modify the mutable point. What I'm actually going to do is create a new immutable point class. And we're actually going to copy everything and paste it here and make the modifications that are appropriate. Immutable, immutable, and there we are. Now, up to now, it's exactly the same as immutable point. What we're going to do is, first of all, we can enforce immutability in many different ways, but the instance methods is already a great place to start. The x and y were not declared to be final, and this makes the instance variables themselves mutable. So if we start by placing a final modifier here, that's already a great first step to making this class immutable. Because even if we wanted to, we could not modify the value of x and y. Now, the compiler will actually help us here and will show us two errors in the setters themselves, which is where we were trying to mutate. So now we'll erase the setters and we'll keep only the getters. And now we already have an immutable class. Now, as I said before, immutability is something that you have to check as a programmer. You have to make sure your class is immutable by not allowing any code to mutate your class. If we go back to the main, and if we were to do this again with the immutable version of the point class, we would not be able to find this behavior here. Why? Well, because we would not be able to set the new x and y values. Therefore, if we wanted to actually edit the locations and add them to a second collection, which is the end locations, we would be forced to actually make new points. And those new points would have the new values, 100, 100, and minus 10, minus 20. Now, I'm not going to show that now because it's kind of the same code that we have here. But if you take the immutable point class and you try to replicate this code, you'll quickly see that you cannot modify the immutable point and that you're forced to create new immutable points, new immutable points, which you could call my end location, your end location, and you could call these my start location and your start location. This helps us make programs that have a smaller chance of actually being incorrect. So, my advice is, when you're starting a new class, try, especially with simple classes, try your best to make them immutable. And if mutability turns out to be necessary, you can add it later on, and hopefully in the smallest amount possible, like, for example, making one field mutable if we have to. Well, that's it for today's tutorial. I hope you liked it, and well, we'll see you next time.